Okay, in the last lesson, we did the surface area. This kind of looks familiar, but it's the surface area of a prism and a cylinder. All right, starts with the same letters, but they're two different things today. But it's very similar to what we did before. So let's talk about what a pyramid is. So I just happen to have a pyramid right here. And in fact, this is not just any old pyramid. This is a regular. I'll put regular. We've talked about regular surfaces before. Not regular surfaces, but let's see, regular polygons before. So this is a regular pyramid. Now, why is it regular? Because the base is a regular polygon. In this case, it's 4 sides, so it's a regular quadrilateral, which means it's a square. All right, so, but you could have 4 sides. You could have 3 sides, really. A triangle at the bottom. You could have 4, 5, 6. It doesn't matter how many. Okay, if all the sides and all the angles are equal to each other on the base of this, then we'd call this thing a regular pyramid. Now, what's the difference between a pyramid and a prism? Remember, on a prism, the sides went straight up. You had 2 bases. You had one on the bottom, one on the top, and the sides went straight up or perpendicular to the base, and that would have been the height of it. But notice what's different here. It starts off the base, and it doesn't go perpendicular. In fact, it doesn't even just go straight up. They all come to one point. So they all the vertices, or I shouldn't say that. Let's see, how would we say it? All the sides come up and meet at one point right there. And let's make that a different color so I can actually see it. Let's make that red. Okay, so that point right there, and it has a name, and got a little ahead of myself earlier. That's a vertex. And so we call that the vertex of our pyramid. A couple other things. I just grabbed this from the internet thing. The internet thing. You know, you've heard of the internet before, haven't you? Well, anyway, this is the height of it right here. Now, look where the height starts. It starts at the vertex, and it goes, we don't say it goes straight down. We say it goes perpendicular to the base. So let's talk about the base. And the height is obviously shown right here. The base is the bottom of this. It's whatever it's sitting on. So this whole thing right down here, okay, would be the base of this pyramid. Notice the height is perpendicular to the base, and that makes sense because the whole chapter 11 we talked about that, found the area of a parallelogram, the area of a triangle, area of all kinds of stuff, that the height was always perpendicular to the base. Figure this as a flat part, and this starts right at the very top where all the things come together, and then it goes perpendicular, or I know what you want to say straight down, but it's perpendicular to the base. And it doesn't look like it's really sitting on anything because you don't have this completed right here, but it is. It's sitting on the bottom of it, so it is kind of completed right there. So that would be the height. There's another height. It's called the slant height, and it's different. It's also perpendicular, but watch what it's perpendicular to. It's not perpendicular to the base. It's actually perpendicular to one of these edges, and they call this the base edge. So the bottom of this thing right here, they call the base edge. All right, so what is the slant height? I tell people all the time, it's like if you're sitting on top of this pyramid, okay? It's like a wild ride or something. You're sitting on here, and if you go sliding down the edge of this thing, so you're not going inside it, you're sliding down right down here perpendicular, and you've made a right angle, your direction is a right angle to this base edge right here, that would be the slant height because you're going down the slant. This one, it's like this. If you're, I don't know, you ever watch Indiana Jones where he climbs in that hole and he's got this rope, he goes down this rope and he goes straight down, right? That would be the height. So you're going actually inside of the pyramid. Remember all the snakes? These are snakes, all squiggly. All right, so they're all the snakes that Indiana Jones encountered. Remember, he hates snakes. Anyway, have you ever seen the movie? It's actually pretty good. It's kind of old now, but I remember when it first came out. We all went to the movies and watched it, and it still holds up. Still a good movie. Anyway, how did we get into that? I don't know. That's the height, and this is the slant height. Two different things. Now, in our book, now it always depends on which book you're dealing with, but in this book, the height from the vertex perpendicular to the base, they'll always use the letter H. For the slant height, they use the letter L. It's kind of like a cursive L right there. So they use the letter L for the slant height. So you'll see some formulas when they use H, it's this one right here going straight down the middle of it. It's perpendicular to the base. The slant height obviously is the one going down the slant, down one of the sides. it's kind of tilted in, and we use an L for the slant height. Okay, so we know the slant height's perpendicular to the base edge, and let's see, what are some other things? Sometimes I'm looking in the book, sometimes they call this height right here the altitude. Remember, altitude is perpendicular to the base, so sometimes they'll call it the altitude, but for the most part they call it the height. But I'm looking at the book, and in that example on page, not example, but that little diagram on page 838, they actually call that the altitude. So height, I'll put in parentheses again, or you could call it the altitude. All right, we'll probably stick with the height. Let me see what else they tell us. The lateral edge. What's the lateral edge? The lateral edge is this one right here. Okay, these sides going here. The base edge is the one that, you know, is on the base. It's the side, okay, that makes up that base. Well, the side of, or this little part right here, this little edge of the side, see how it makes a triangle here, there's a triangle here, and there's one back here, and there's also one back there. This would be called the lateral edge. Lateral means side, so it's the edge on the sides. So it's the lateral edge. All right, so that's the lateral edge, that's the base edge. This one's the height, the slant height. You got a vertex, you got a base. I should have, we'll put that word right there. So you've got a base, that's the bottom of it. Let's see, did we cover everything? I think we did. I think we covered everything on this, as far as just labeling the stuff on our pyramid. And it's important that you know that, because you're going to have some formulas here in a little bit, and they're going to talk about the base, they'll talk about the height, they'll talk about the slant height. The base edge and lateral edge, they probably won't talk too much about that, but definitely these biggies right here, the height, slant height, and base, are the ones you really need to make sure. Now again, this is a regular, this one's regular. Now there are irregular pyramids. Let's just take a look at that. But the formulas that we're going to use in this section right here are only going to deal with regular pyramids. I'll show you what an irregular one looks like, but for our formulas, we're just going to deal with regular. Okay, here's an example of a non-regular. We'll just call it non-regular pyramid. All right. And why is it a non-regular pyramid? Because if you look at the base right here, and the base, well, actually there's base right here. Okay, didn't realize that they actually drew it in there. There's a base right here. If you look at it, it's not a regular polygon. And look at the edges. The edges don't go straight up to a point. Okay, if I went, let's see, how should I say this? We'll just say this. We'll just say that if you look at this angle right here and this angle right here, they're not equal to each other. This side right here and this side right here would not be equal to each other. So if it's a non-regular base, then it's a non-regular pyramid. All right, so that's a non-regular pyramid, and that's all we got to say about that. We're not going to deal with anything with that. I just wanted you to look at it, and the ones that they give you in the book, I'm looking at it, I'm looking through here, and it looks like they're all going to be regular pyramids, but I just wanted to show you what a non-regular actually look like. Okay, let's take a look at a formula, then we'll do an example and we'll move on. Okay, here's a different picture, but it's the same basic idea here. What we're going to do first, we want to find, here's what we eventually want to do. We want to find the surface area. Let's do this. Let's call it the total, just so we don't get confused. We're going to find the total surface area of this pyramid. And it's a regular pyramid, but we'll just say pyramid. Okay? So let's figure out how we're going to do this. Well, first of all, we've got these faces. I probably should have talked about it. See this triangle right here? That's called one of the faces. So we actually, if this is 4 sides, we actually have 4 faces. If the bottom, if the base was a pentagon, we'd have 5 faces. Hexagon, 6 faces, that kind of thing. All right, so depending on how many sides we have on our base, that's how many faces we're going to have. We could find the individual face, the area of that, and then just multiply it by how many faces we actually have. But this way is a little bit easier, I think, sometimes. What we're going to do is we are going to find the lateral surface area. We've talked about that before. What does that mean? It means all the sides. So actually, we're going to find what the lateral surface area is with one formula. Instead of finding one triangle and multiplying it by how many triangles that we actually have, we're going to do it what I think is a little bit of an easier way. Remember, these are triangles, so remember what the area of a triangle is, 1/2 the base times the height. This kind of comes into play here. It's going to be 1/2, Now, instead of just one base of the triangle, since we're going to do all at the same time, we're going to go the perimeter. That's why they put this P right here. This is the perimeter. See, it's in that yellow color. That's the perimeter of that thing. So it's going to be 1/2 the perimeter times the slant height. Now, why do we use the slant height? Because remember, we're trying to find the area of this triangle. This slant height is actually the height of this particular triangle. All right, so that's what we're doing. We're basically finding one triangle and multiplying it by how many sides we have. That's why we use perimeter. So it's 1/2 the perimeter times the slant height. It's basically like 1/2 the base times the height multiplied by how many sides you have. That's what you're doing when you're finding the perimeter. Hope that makes a little bit of sense. So that's the lateral surface area. It's 1/2 the perimeter times the slant height. Remember, this is the slant height. They'll give you the height. Well, it depends what they give you on the problem, but this would be the height right here. This would be the slant height. You can tell they're definitely different lengths. So you find the slant height, and then you multiply it by the perimeter. Take half of it. Why do you take half? Because we're dealing with triangles, and that's what the lateral surface area would be. There are some problems that say, in fact, we just, on that 12-2, I think they asked you almost every single problem. Find the lateral surface area, then find the total surface area. Well, the lateral surface area is this, but I'll tell you what, let me get away from that. Now, let's find the total. How do I find the total surface area? Well, you got the lateral surface area, the 1/2 PL. What's left? What else? What other surface do you have? Well, you got the base of this. Remember, if you wanted to paint it, what sides would you paint? You'd paint all 4 of these triangles, plus you turn that pyramid over and you paint the bottom of it. Okay, so you have the 4 sides and the bottom. We don't call it the bottom, we call it the base. So what I would do is they just use the letter B for the area of the base. You could sit here and just memorize this, or you could just kind of intuitively see what you're doing here. You're saying, okay, it's 1/2 PL, so that's going to give me all 4 of those triangles. Then I got to add the base to it, so there you go. So it just kind of makes sense. It's not like it's a brand new formula that you didn't know. Both of these things kind of make common sense if you really think about it. But they just kind of put it in one pretty package like this, and that's how you find the total surface area of this particular figure. Now let's do this. Let's take some things. Well, we could probably just use this picture right here. It's very difficult for me to draw these 3-dimensional pictures. Some people are really good at that, and they see spatially, and they see, you know, how to draw this. I'm really bad at it, even with my lines on my program that I have. So I'm going to stick with the pictures from that I find on the internet. So let's take this basic picture right here. We'll put some numbers in there and then see what we can actually solve for. Okay, it's the same picture. I just put a couple of values in here. So the bottom, now it's not the perimeter. I kind of scribbled out the P for perimeter. Just this bottom right here, this edge, what do we call this? The base edge is 12. The height, we made 16. And what they're asking for is to find the total surface area. We want to find the surface area of this whole entire thing. So we got to go 1/2 PL. All right, well, I know what 1/2 is. It's 1/2. Okay, I know P. I can figure out P pretty easy. 12, 12, let's see, 12, 12, 12, 12 times 4, which is 48. So that's pretty easy. The lateral surface area. Do I know the lateral surface area, the L? Or no, I'm sorry. I didn't mean lateral surface area. The L is the slant height. Sorry about that. Do I know the slant height, the L? No, I don't. They tell me the regular height. I don't even see regular height in here. How's that going to help me? Well, that'll help me. But I want to find the slant height. Don't know that. I'm going to leave it blank. Plus B. What does B mean? It means the area of the base. Well, what kind of base do we have? We have remember, they're regular polygons, so all the sides are 12. And then it's regular, all the angles are equal, so it's a square, isn't it? If it's a regular quadrilateral, it must be a square. So that's 12, and that's 12, and that's a square. So how can I find the base? It's just the base times the height. Remember, it's a square, so it's base times height, which is 12 times 12. All right, so that's what we're going to have for the base. So really, the only thing I have to do is to find the L, find the slant height. Well, let's think about how we're going to do that. How in the world are we going to find the slant height? Well, if you think about it, let's see. This is 16. Remember, it's perpendicular. Remember that? It's perpendicular to the base. So it kind of looks like we might have a right triangle here. Now you could draw this a couple different ways. I think I'm going to draw it like this. Let me get a little bit of a darker blue, like that, trying to match that color. See, the slant height is right here. Well, there's actually 4 slant heights. I mean, they're the same number, but you can see it 4 different ways. You can see it on this face. You can see it on this face. You can see it on this back left one. That's exactly what I'm going to do. I'm going to go from here. Where would the slant height go? It would go to there. If you notice, the slant height on a regular polygon, it actually hits the midpoint of this base edge right there. Okay? And also the height, it actually hits the center of the square, which means they call it R for radius, I guess. So this distance would be the same as to this edge and to this edge and to this edge, the perpendicular distance. All right, so look what we have. We actually have a right triangle. You see that? Now the R, do I know what the R is? Well, let's make this green, make it kind of look the same. So what is the R, the radius? Well, this hits right dead center. The whole thing is 12. So from here all the way to here would be 12. What do you think the R is, the radius? It's kind of like diameter and radius of a circle. So the radius would be half of the 12, which would be 6. See, here it comes right to here. So that would be half of the 12. So that would be 6. So check it out. Now I can actually find the slant height. And let's put the L right there for slant height. I just did it over here so I could get a nice little right triangle. I already had the radius drawn and the hypotenuse, so I drew this blue one and made it the L. It's the same length. I know it doesn't look exactly the same length, but remember, this is 3-dimensional. It's hard to get a good grasp of a 3-dimensional object on 2-dimensional surface like this. But that would be the same as this right here. So now what do? Just Pythagorean theorem. So we go, let's see, so L squared is 6 squared plus 16 squared, and you can do the math. I'm just looking in the book right here, and it comes out to the square root of 292. All right, whatever that is. We'll put it in the calculator in a little bit. I'm not going to put it into a calculator now, then put it in. I'm going to actually put in, let's keep the same color coordination here. I'm going to put in the square root of 292. So remember, that's all we had to do was find the slant height. So you just have to kind of visualize. The picture absolutely is helpful here, but notice that the slant height, the height, and the radius make a right triangle inside of that pyramid. And that's very important to know. So that can be very, very helpful to you. So now we found the slant height. We just stuck it here. And then you do all the work. I'll let you throw that into a calculator, and you should get 554.1. Okay, and whatever the units are in, yeah, it's centimeters. So this is centimeters squared because it is area. So what'd you just do? You found the area of all 4 sides. That would have been this number right here. And we didn't even have to get a separate number for this, a separate number for this, and then put them into our calculator. I could have stuck it all in the calculator, all in one shot, and then you should get 554. Make sure you practice that. Don't just sit there and watch this video and say, okay, whatever, you stick it into a calculator. Make sure that you put it in the calculator correctly because there's a few steps that you have to do here. So do practice that before you go on any further. Okay? And I'm looking. Let's do one other pyramid one, and then we'll go to the cone. Okay, now we're taking a look at it's another pyramid, and it's regular, but look at the bottom. It's not a square this time. How many sides? 1, 2, 3, 4, 5, 6. 6 sides, so it's a hexagon. Or you could call it a hexagonal pyramid. All right, so it's a hexagonal pyramid, which means the base is a hexagon. And it's a regular, all right, put it up here. It's a regular hexagonal pyramid. So it sounds like a mouthful, but all it means is the base is a hexagon, and all the sides and all the angles on the bottom are equal to each other. We want to find the surface area. We want to find the total surface area of this whole entire thing. Oh, excuse me. So let's see how to do that. How do you find the total surface area? Well, let's do it's the lateral surface area basically plus the area of the base. So how do we find the lateral surface area? It's 1/2 the perimeter times the slant height. Let's make that look more like a P. There we go. So it's 1/2 the perimeter times the slant height plus the area of the base. Well, let's see what we can do first. let's plug some stuff in. Remember we did this earlier, we put the parentheses and stuff, so we know what 1/2 is. What about the perimeter of this? Do we know the perimeter? Well, they do tell you one of these edges right here, this base edge, it's 5. There's 6 sides, and they all have to be equal to each other, so 6 times 5, right? 6 times 5 is 30, so we'll put a 30 right there. Times the slant height. Now, on the other problem, we had to find the slant height. Do we know the slant height of this one? Absolutely we do. It's this one right here. That red one, I kind of drew that in myself. It's perpendicular to the base edge, and that's 8. That's the slant height right there, that 8. So I'll put an 8 there. Plus, now what is this? What is the B? It means the area of this whole entire base. You're like, oh my goodness, I don't know the area of this whole entire base. They don't tell it to me. I'm going to have to figure it out. So what kind of base is it? It's a hexagon. So I just happen to have a hexagon sitting right here at my disposal. And so what I want to do is I'm going to take a look at this and just find, let's scoot this up just a little bit. I don't even need the picture anymore. All I need is this, because this is the area of the base of that hexagon. The only thing I know about the hexagon is that the base is 5. Well, we just had a test. We just had it last week on how to find the area of this thing. So hopefully you remembered from just a week ago how to find the area of this, and we're going to stick it in right here. Okay, we're going to put it in right for the area of the base, chuck all this into our calculator, and then we'll get the surface area of that whole entire thing up there. So really, the lateral surface area is a piece of cake, because they gave you everything you needed to know, basically, for the lateral surface area. It's the area of the base that's a little bit more difficult. So let's try to remember how to do that. I'll go through it kind of quick. Remember, it's a hexagon, so I'm going to do this. Remember how that was helpful? I could have done it to all 6 of these. But remember, you take the 360 divided by 6, which is 60. So I'll just show it to you again. 360 divided by 6, because there's 6 angles, there's 6 sides, there's 6 angles, so that would be 60 degrees. This whole thing would be 60, but what are we trying to really find? We are trying to find from here to here. Remember, forget the whole pyramid thing. Just concentrate on this right here. This is what we learned in the last chapter. So we want to find that, which is the apothem. So do you remember the area of a regular polygon is 1/2 the perimeter times the apothem? There's a lot of, look, that looks kind of close to it, doesn't it? But this is for this particular base right here. So remember, this angle is 60 degrees, and that would be 30 degrees right there because it bisects it. Also bisects this side, so this would be 2.5. This side right here. What are we trying to find? Actually, I don't even care that that's 2.5, to tell you the truth. All I care about is what the apothem is. This is 30. That's 60. Let's get rid of all this mess with the 2.5. I don't know where I was going with that. Okay. And, well, actually, I do need to know that's 2.5. I knew there was a reason for that. Remember, that whole thing is 5 right there. So that's 2.5. That's the short side. It's a 30, 60, 90 triangle. You could do trig functions if you wanted to, but the reason we learned 30, 60, 90 is so we could do exactly this right here. So this is the long sides opposite the 60. So what's the relationship? Well, the long side is the square root of 3 times the short side. So A is equal to 2.5 times the square root of 3. That's the apothem. So let's put some stuff in here. So it's 1/2. The perimeter of this, now we didn't really even talk about the perimeter. Remember, one of these sides is 5. There's 6 of them. So 5, let's do this. 5 times 6 is 30. So this would be 30. That's the perimeter. Times the apothem. We just found the apothem. Remember, this is the long side of the 30, 60, 90. And it's the short side times the square root of 3. So it's 2.5 square root of 3. I know it's a lot of stuff. Okay, but that's, you're almost done the year. So you know you're going to have some hard stuff at this point. So this is what? This is the area of the base. This is that B right there, the area of the base. I just redrew the base just to make it look a little cleaner, a little prettier. Found the area of this whole entire thing, which is whatever that number is. I don't even care to put this into a calculator just yet. What I'm going to do is I'm going to take all this and I'm just going to chuck it right here. And if you want to rewrite it, you can. You just put 15, right? Half 30 is 15. It doesn't make any difference. All right, all this stuff right here, I'm going to chuck into the calculator, and hopefully you get the correct answer. I'm going to look at the book, and their answer says 184.5. 184.5. And it's in, I don't know what the units are in, centimeters, so it's area, so it's centimeters squared. Okay? So that's how you do it. Well, that was a lot of stuff. Go back, rewind it. That's what's good about the video. You don't have to just say, oh no, I didn't get it. I'll never be able to get it now. No, rewind, see what I said, and I don't have to repeat myself here. Let's try. We're done with the pyramids. Let's go to a cone, and then we'll be finished. All right, this thing right here is a cone. All right, it's kind of like an ice cream cone, but you turn it upside down. Right, you got the pointy end on top, and that's what it is. It's a cone, but it's a geometric figure. Okay, what is a cone? Well, it's kind of like a cylinder, but the sides don't go straight up, and you don't have two bases. This is really close to a pyramid. That's why they put them in both of these in the same lesson, because it's basically a pyramid with a base that's a circle. Okay, it's not a regular polygon, it's an actual circle. So it's kind of the same thing, and some of the formulas that we're going to use are directly related to this, very closely anyway, related to this. So let's see, you got the height from the top, they even labeled the vertex right here, and you got the height, which goes perpendicular to the base, so it goes right to the center. That's going to hit right at the center of the circle. Okay, of course, this would be the radius of the circle from the center to the edge, so that would be a radius. And this one would be the slant height. Again, if you sat on top of it and you slid down this slide right here, you wouldn't be going straight down, you'd be going down the slant. That's the slant height. Again, we use L. Oops, I'm in white. White, it's not going to work. So the slant height, we use L, and the actual height, we use the letter H. Of course, R for radius, obviously. Okay, so that's what a cone is. Now, the only thing different is the lateral surface area. Oh, we'll stay blue. The lateral surface area, it's not 1/2 the perimeter times the slant height like it was on a regular polygon. It's this. It's pi r L. You know what pi is, 3.14. R is the radius, and L is the slant height. So if you take the slant height, multiply it by the radius, times it by pi, you've got the lateral surface area. This is that whole surface right here. So if you held that ice cream cone, that's the lateral surface area. Okay, it's not the flat part on top. You don't even make ice cream cones. Usually that's a hole right there, but pretend you stuck a top on it, okay? Then that would be the base. So this right here is the base, that circle, and then everything else is the lateral surface area, okay? It's pi r L. That's something that you have to memorize. All right, there's a lot of stuff to remember, so you got to go over this every night. Remember these formulas. There's a little chart. They give you a little chart on page, where is it? 842. Write that down. Page 842. There's a nice little chart that has all the pictures we've talked about so far, and it gives you all the formulas all in one nice place. So look at page 842, bookmark it or something so you can see it. So the lateral surface area is pi RL. What if you wanted to find the total surface area of this? So what if you wanted to find the total surface area? Well, you take all the sides, which is pi RL, that's the lateral, plus the area of the base. You could just put B right here, but since it's a circle, you know exactly what the area of a circle is. It's just pi r squared. So if you want to memorize that, you can, but really this is the only thing that I memorized because I already know the area of the circle is pi r squared. So what I do is I remember, oh, that whole cone is pi RL, and then you just add it to the base. Well, what's the base? It's a circle. So what's the area of a circle? Pi r squared. I wouldn't sit there at night, okay, when you're studying saying, okay, the total surface area of a cone is pi RL plus pi r squared. Pi RL plus pi r squared. No, I wouldn't do that. Memorize this part right here, pi RL. But just instinctually, is that a word? You should be able to figure out, oh yeah, this is the base, this is the lateral. Just add them together, and you got the total surface area. Okay, let's do a, I'm at 30 minutes now, so let's go to an example, and we'll be finished. Okay, this one's tailor-made for you. This should be pretty simple. So we're trying to find the area of this cone. Area of the cone. Not a pretty orangish, yellowish color. So what do we know as far as the area of the cone? We need to find the lateral surface area. Do you remember how to find the lateral surface area? It's pi RL. Hopefully, it was only like 5 seconds ago I had it up there, okay? So the lateral surface area is pi RL plus, what else is on here? The bottom of it. And what is it? It's a circle. What's the area of a circle? Pi R squared. So let's see. Do we have to figure out anything? Not really. Well, you kind of do. Look, what they do is they tell you this whole thing, this whole diameter of the circle is 14.8. You're not going to put that in there. You got to find R. So what is R? Well, it's just half of the diameter, so that's just 7.4. That's really the only thing a little bit tricky about this at all. The rest of it is just plug into a formula, plug and chug. So what do we get? We get pi, and then R, make sure R is 7.4, it's not 14.8, times L. And look, they were nice. They told you what the L was. They told you it was 15. They couldn't have made this any easier. And then plus pi, and then again R again, which is 7.4. It's the same radius. We square it. And then I'll let you do all that work. You chuck it in your calculator and you should get 520.8. And that's in, what do they put it in? It's in centimeters again, so it's centimeters squared, its area. And that's how you do that. Let's do one more. I know we're a little over 30, but we got to do one more because that was way too easy. We got to do one that's a little bit more challenging. Okay, here's the last one we're going to do. Looks a little cartoonish looking. I got this off the internet too. I guess I could have drawn that thing. But anyway, we're going to find the surface area of it. So let's write it down. Let's find the surface area. What is it? It's pi RL. That's the lateral surface area. Plus the base, it's a circle, so it's pi R squared. Pretty easy. Let's see. I know the radius, which is 6. The only thing I don't know is the L. I'm going to have to figure out what that is. But if you're looking at it, you're probably thinking, oh, I can find that. That's no big deal at all. And I know the radius. So really, the only thing we have to do is a little Pythagorean theorem here. So let's see. I've got 6 squared plus 7 squared equals L squared. That's 36 and 49. And let's see. That's a 5. That's a 7. That's an 8. So it's a square root of 85. I'm just going to keep it like that. I'm not putting it in my calculator just yet. I'll just keep it the square root of 85 because I can do it all in my calculator in one shot. So now, really, that was all the work, basically, that you had to do. So you take the pi, times it by the r, which is 6, times it by the L, which we just found, which is the square root of 85, plus pi, and then r squared again, which is 6 squared, and we'll chuck all that into our calculator. This problem is not done for me in the book, so let's see if we get their answer. Actually, they do have the answer there, but let me just for fun, you don't mind, do you? So let's do this. We got 6 times the square root of 85 pi right there, plus let's see, we'll go 36 pi, is that all right? Plus 36 pi, like that. Hopefully we'll get the right answer. 286.89 or 88, which is 9. Yep, that's exactly what they have. 286.9. So 286.9 square whatever it is. This time it's inches, so it's square inches. And that's the answer. That's the surface area of this whole thing. Okay, the lateral surface area plus the bottom. That's how you find it. All right. That's it. Sorry it took over 30 minutes. I really am trying to make these shorter, but enjoy this lesson. We'll see you next time.